But please do yourself and myself a favor, have out your orange tables right now. Your orange trig tables, this will go a lot quicker if you can have those out and help me along. This shouldn't be a very long example, especially since I feel like you guys have a pretty good understanding of how to do the first derivative test. The only reason I'm doing this example with you is because it's a trig function, and you guys always seem to get a little bit nervous when you see a trig function. So I want to go over one with you. This is the only example that we're going to do today. F of x is equal to 1/2 x minus the sine of x. And we are just going to answer this question in terms of one revolution around the circle, from 0 to 2 pi. So the first thing that you need to do, of course, is find the derivative. So help me out here. The derivative of f of x is equal to, what is the derivative of 1/2 of an x?
1/2.
It is 1/2 minus the derivative of sine of x is the cosine of x. Is everyone okay with why I did not use the product rule here? It's 1/2 x. It's not times the sine of x. It is minus the sine of x. So we are not multiplying anything here other than the half and the x, but that doesn't count. It's not a polynomial times a polynomial. So, all right, so we have 1/2 minus the cosine of x. Right now, we need to determine whether or not there are any issues with this thing right here. Are there any things that are going to give us something not acceptable in math, like divide by 0 or square roots of negatives? So this is a trig function, though, and those sometimes have undefined situations. So look at your cosine row on your table. Is the cosine ever undefined?
No.
The cosine is never undefined. Therefore, there are no issues with it. So the next thing that we need to do is do what? Put it equal to 0. So I'm going to put this thing equal to 0, and we have to solve for x. So we have 1/2 minus the cosine of x equals 0. What do we do to solve for x? Get rid of the 1/2. How do we get rid of 1/2? Subtract it. So I'm going to subtract it from the left. I'm going to subtract it from the right. So I am left with negative cosine of x is equal to negative 1/2. Divide by negative 1. I'm not even going to do it because I think you guys are smart enough to know that when you divide by a negative 1, it's going to turn this negative 1/2 into a positive 1/2. So you're going to have the cosine of x is equal to a positive 1/2. Your job right now is to look on your tables and decide what values of x, what thetas get you 1/2. Okay, so x is equal to, what did you guys just say? Pi over 3 and 5 pi over 3. These, what do we call these? Critical numbers. Those are your critical numbers. So far, so good?
Mm-hmm.
2 critical numbers, which means I need to check
3.
3 regions. Can I flip pages?
Sure.
Where was the
Where's the what?
The third one.
No, there's 2.
Oh.
There's 2 critical numbers, so we're going to check 3 regions. That's what you heard. All right, so my 3 regions. I'm going to write down my critical numbers. My critical numbers were pi over 3 and 5 pi over 3. All right, now remember, you guys, we were only doing this problem from 0 to 2 pi. Normally, when we have done this, we have went anywhere as far as from negative infinity to positive infinity. Right now, we are only going from 0 to 2 pi. So we're not going to do regions starting at negative infinity. We're going to do regions starting where?
0.
We're going to start at 0. Yeah. So our first. Okay. Normally, they don't give us a start and end. They just say look at the entire graph. So that's why we go all the way from negative infinity to positive infinity. That's why our regions always start with from negative infinity to our first critical number. But in this case, they told us we are only going from 0 to 2 pi. So our first region starts at 0, okay? So the first region is going to go from 0 to where? Pi over 3. Our second region is going to go from Yep, our first critical number to our second critical number. And then our last region goes from 5 pi over 3 to where? Where does it end?
2 pi.
2 pi. It has to end at 2 pi. Very nice. Alright, now this is the part that would it would be tricky if you didn't have your trig tables in front of you, but you should have your trig table in front of you. And what I need you to do is give me a value that falls between 0 and pi over 3. Pi over 4?
Yeah.
Alright, let's try that. X equals pi over 4. You don't have to use that, but you can. Now what you need to do is give me something that falls between pi over 3 and 5 pi over 3. Give me something nice.
Pi.
Pi?
Yeah. That's wrong.
Alright, and now you need to give me one more number that falls between 5 pi over 3 and 2 pi.
7 pi over 4.
Really? There's no nice like 3 pi over 2 or anything like that. Alright, 7 pi over 4 it is.
What's the first one?
Pi over 4.
Oh, 5 pi.
So go to your derivative. Type it into y equals. Type your derivative into y equals. Your derivative is a half minus cosine of x. Do me a favor, make sure your calculators are set to work in radian mode, because I know some of my classes they had to switch into degrees today. One of my classes did. So make sure yours is set in radian mode. 1/2 minus the cosine of x. Do a table start at pi over 4. Don't worry about what its real value is. Just do a table start at pi divide 4. What do you get?
Negative.
Get a negative? Alright. That means that it is decreasing. What happens when you do a table start at pi? Increasing. What happens when you do a table start at 7 pi over 4? Alright, so let's stop and talk about what's happening. First of all, whatever the graph looks like, it's heading in a negative direction, and then it's going to switch to a positive. So what does that mean about pi over 3? It is a minimum value. So we have a minimum at pi over 3, comma something. We'll figure out what that something is in just a minute. And then, I'm sorry, what?
Why would 5 pi over 3 be the minimum? Because of your stopping at 5 pi over 3. And then you're going down. Sorry.
Nope. Okay, so from 0 to pi over 3, we have a negative slope. So the graph is going down. After 5 pi over 3, but before 5 pi over 3, it's heading back up again. Okay? And then from 5 pi over 3 to 2 pi, it starts to go down again. Okay? So we have a minimum at pi over 3. We have a maximum at 5 pi over 3. Your job now is to go back to y equals, type in your original function. I can't even remember what it was anymore. A half x minus the sine of x. Type that in. Do table starts at pi over 3 and 5 pi over 3. Yes.
To get the negative and positive, what did you type into the calculator?
The derivative.
Now it's 1/2 minus cosine.
Are you in radian mode?
Yeah, but when you type in, wait, this might seem weird. You just put it like an X. Like,
Do a start at.
no,
You're making a table.
like this. What is this? Look like?
Which What do you get? You get a crazy decimal, right?
Yes.
Yeah, that's okay. What do you get?
Negative
Negative point
3.34.
3, 4, 2, 4? Sorry, it's so awful now. Alright, what about?
It's point 3424. What is it?
Negative point 3424.
Oh, gotcha, okay. Negative. Negative point 3, 4. I'll just say 342. What happens at a start at a 5 pi over 3? 3. And there's a good chance that if you're using the solution manual has these values in terms of square roots and fractions and stuff, but I'm okay with you guys just giving me decimal answers.